Hey, everybody. Thanks for tuning in to What's Up with Giancarlo. All right, we're going over topic 2, lesson 1 today in our book. So, we're going over understand proportional relationships, equivalent ratios. So, the little lesson you'll learn today is I can test for equivalent ratios to decide whether quantities are in a proportional relationship. That's what you'll learn. It looks a little weird because I had to enlarge it. So, obviously when you enlarge pictures, you lose quality, okay? Everything should be in your book though. And if you don't have a book, hopefully it's clear enough for you to read. Skip over that part. Okay. Essential question. How are proportional quantities described by equivalent ratios? Okay. If they are equivalent ratios, then they will be proportional. It's if I'm comparing two quantities and then all the ratios between them are equivalent, then the two quantities will be proportional. Example one, recognize a proportional relationship. On China's favorite mobile game, she is awarded game lives when she finds gold coins. How is the number of game lives awarded related to the number of gold coins found? Okay, so for 3 gold coins, she got 9 free lives. For 2 gold coins, she gets 6 free lives. And for 5 gold coins, she got 15 free lives. Okay, class, when you simplify all of these, you're going to break them down, simplify them to the best you can. You'll get 1/3. Divide this by 2 and divide this by 2, you'll get 1/3. Divide this by 5, divide this by 5, and you'll get 1/3. Class, the fact that all of these ratios break down to the same simplification, 1/3, that means that they are all, one, equivalent ratios. They are all equivalent ratios. And two, that the two quantities are proportional. Okay? So this is just going over the same thing. Let's look at it. 3 coins for 9 lives, 2 coins, 6 lives, 5 coins, 15 lives. They break it down into the simplified version. They all equal 1/3 like I did. Two quantities are in a proportional relationship if all the ratios that relate the quantities are equivalent. They are all equivalent, therefore they are proportional. It is a proportional relationship. The number of game lives awarded is proportional to the number of gold coins found. So, example one, recognize a proportional relationship. Try it. Here's all the information. 1.25, 25, 3.6, 72, 6.25, 125. Class, fill in the boxes, okay? Fill in all these boxes. These are both words. I'll give you a little bit of time to work it out. Pause it right now. Okay, class. So they give you all the information you need. 25 over 1.25. Okay? And then, like we saw the 25 on top, the 72 will be on top. And then we're looking at both of these. If they both equal 20, I'm just going to go ahead and say that this equals 20 also. So it looks like they're all equivalent when you break them down. The ratios for each pair of data are, you guessed it, equivalent. So the download time and the file size, the two quantities, if the ratios are equivalent, the two quantities are proportional. Perfect. Okay, you can pause it and write everything down if you need to. But let's move on. Example 2, decide whether quantities are proportional. Is the relationship between the area and the side length of the squares proportional? Question mark. Explain the reasoning. So this is 2, 3, and 4. They work it all out for you, okay? When we simplify 4 over 2 and 9 over 3 and 16 over 4, we get 2 over 1, 3 over 1, and 4 over 1. These do not equal each other, and these do not equal each other. Therefore, these quantities are not proportional. The ratios have to be equivalent for the quantities to be proportional. These ratios are not equivalent, therefore they are not proportional. Let's move on. Example 2, decide whether quantities are proportional. Try it. The table at the right shows information about regular hexagons. Is the relationship between the perimeter and the side length of the hexagons proportional? Explain. Class, try it. It's very easy. I'll give you, pause it right now. I'll give you a few seconds. All right. So you can write it how you want, 12 over 2 and 18 over 3, or 2 over 12 and 3 over 18, whatever. You're going to solve them the same way. This is going to equal 6 over 1. This is going to equal 6 over 1 when you simplify. This will be 1 over 6, same thing, 1 over 6. All you need to see is that they equal each other and they are equivalent. The ratios are equivalent, therefore they are proportional. Okay? When we simplify them, they are equivalent. Okay? Example 3, use proportions to solve problems. A proportion is an equation that represents equal ratios. Use the table at the right. How many times will a hummingbird beat its wings in 60 seconds? So these, in 2 seconds, 167 seconds, 560, in 10 seconds, 800, okay? We're trying to find out how many times it will beat its wings in 60 seconds. So they simplify all 3 of these to find out that they are proportional, and it'll be 80 over 1, okay? So the way we work this out, we have 80 over 1, 80 beats per 1 second, equals a variable x over 60 seconds, okay? So now all we have to do is cross multiply, okay? So we get 1 times x equals x, and then 80 times 60, 8 times 6 is 48, and then you can just add the 2 zeros. So 60 seconds will be 4,800 beats. Okay? Go ahead, do the example 3. Try it. Pause it right now. Okay, so we get cups of sugar over cookies equals cups of sugar over cookies. So we get 1.5 over 24 because that's what it relates to. Then we get x over 36. So we have to cross multiply, and we get 24x equals 36 times 1.5 will end up being 54. We divide both of these by 24, and we get x equals 2.25 or 2 1/4. All right, here's the key concept. That's the lesson for today. As you all know, if you're in my class, it's nice to know you. If you're not in my class, welcome to meet you. You've been watching What's Up with Giancarlo. And if you're watching these videos, you're a part of the class. Bye, everyone.